Hi, in this work we are going to talk about the Alzheimer's level prediction based on brain MRI images. First, talking about the relevance of the Alzheimer's, it is a current disease that affects more than 50 million people in the world, and this is a number that can double until 2030, according to experts. And it's a disease that leads to a deterioration of the cognition, affecting not only the individual but also their family members and those close to them. The global cost of Alzheimer's and dementia in general is about $1.3 million. And here we can see a graph that compares the number of people with dementia in low income countries compared to high income countries. And we can see that there is a direct relationship between the country's income and the cases of dementia. This is a disease in which the early diagnosis is essential for planning, effective treatment, and cost reduction. The traditional diagnostic method includes clinical assessments, neuropsychological tests, and obviously MRI scans, but this can often be subjective and expensive. With the solution that we are bringing, we can have a faster and more accurate diagnosis using CNN as the main model of the artificial intelligence. Important: these mechanisms should be seen only as tools for doctors and not the doctors themselves. The database that we choose contains brain MRI images divided in 4 classes of Alzheimer, totalizing 6,400 images. The augmentation used to complete the data includes little flip, rotation, scaling, little change in the brightness and in the contrast, which are differences that can occur in different MRI scans. The model used was the convolutional neural network, that is one of the best AI models to work with images, and we compared a proposed one with the ResNet, that is already a very consolidated CNN. The CNN works like this: we have an input image, it passes through a lot of convolutional layers, a lot of ReLU layers that are non-linear functions, and a lot of pooling layers. At the end, it passes through a fully connected layer to finally separate our images in the classes that we want. We also used cross-validation to generate our results. Using the proposed CNN, we obtained the test accuracy of 76.3% using the original database and 80% using the augmented database. We can see here that the classes that have fewer images available are the ones that the model learned less, like this moderated and mild, a problem that is solved using augmentation. Using HasNet, we obtained a test accuracy of 72% with the original database. We obtained a test accuracy of 72% with the original database and a test accuracy of 77% using the augmented database. In conclusion, our best result was a test accuracy of 80% using a proposed CNN with the data augmentation, which considerably improved the performance of all models in general. We can see too that the most complex model, like a ResNet, is not necessarily the best for your problem. The classes that the model confused most was mild-demented with very mild-demented and very mild-demented with non-demented. Now, comparing with another studies in the area, we observed that our best results surpasses that of Naku-Prano in all the metrics analyzed. However, compared to Sudak, although our results is already satisfactory, this author managed to obtain a higher precision, indicating that there is still room for improvement in the form
Using
of
the model that we trained,
the problem at hand.
a little
For example,
web application
using other models
that you can
and
simply
other
drag your
databases.
file into the field and click on predict, and the model will give you the level of Alzheimer based on the image that you gave. That's all. I hope you enjoyed it. Bye bye.